My name is Nanos Rachel and we are Group 19. We are here to present our temperature alarm system Arduino based project that uses 4 boards to monitor temperature and humidity from the DHT sensor and stores the data and then alert when the temperatures exceed the threshold. This system can be implemented in areas like the server rooms to prevent overheating, warehouses, storing sensitive goods to avoid spoilage, and other industrial environments where the temperature shouldn't exceed the maximum or the required temperature. Then each board has a specific role in this system, and we will walk through it. All boards are connected to the same ground, which ensures stable communication and sharing across the system.
Hello everyone, my name is Banan Shadir and I will be explaining the functionality of board 1. Now, board 1 is this, and it's responsible for collecting the temperature and humidity data. It uses this DHT11 sensor to measure environmental conditions, and we have set up an ADC to convert these readings into digital data that the Arduino can process, and that we shall see that later it is embedded in the code. Then there is also a button on board 1 that allows us to start and stop data collection, and we shall use that method. We use the method called debouncing for this button, which is this one. And now, when you press this button, we use the method called debouncing for this button, which makes sure that the button press is smooth and doesn't register multiple times accidentally. That's the main reason why we apply software debouncing in our code. And now, this board 1 sends data and humidity data to board 2 over a serial connection, and we have achieved that through connecting TX pin on board 1 to RX pin on board 2 to enable the serial communication. So when I press the button, you see the DHT starts sensing data and pushing it. It's displayed on the serial monitor. So that's it from me.
My name is Chigong Wazira Fred, and I'm going to be taking you how board 2 works. Board 2, its main job is to receive data from board 1. Once data is received from board 1, it uses EEPROM to store this data. Reason being, EEPROM is a non-volatile memory found in the Arduino board. So we do this because once power goes off, data stays there within the Arduino board. So when data comes in from board 1 to board 2, board 2 checks if it's valid reading and hence logs it into EEPROM. We use this feature to keep a history of temperature and humidity readings, which might be useful for analyzing trends over time. Once data is saved within our board 2, it is sent to board 3 using another serial communication. Here we connect TX to RX board for smooth data transmission. So once I press the button, data starts to be sent to board 2, as we can see.
Hello, I am Ketra Nanunkoma, and I'm going to take you through how board 3 works. So let me just connect it. So after connecting it, press the button. Yeah, so board 3 is going to receive information from board 2, and its main functionality is to do a comparison as to when the temperature set for your system, the temperature you desired or the humidity you desired for your system is passed. Yeah, so when the temperature you set for your system is exceeded, then this board 3, its main functionality is going to do a comparison with the exceeded temperature and the temperature that is current, the one that is being sensed by this DHT. And then if it's above or it has been exceeded, our buzzer will create the alarm, like it will. So our buzzer noise, if our buzzer noise is not loud enough, then I'll just connect our LED light, please, so that I can show you that our system is actually working. So just connect this. Yeah, so after our connection, the light is blinking as per the sequence you set for the system. So yeah, we set our board 3, we use the GPIO pin that alerts the system whenever the threshold is high. Yeah, so when this when this board is ready to send data or to send data to board 4, then we connected it to our pin ready for GPIO. So when it's ready to send data, then it sends data, and then when it's done sending the data, it toggles the pin back to low. So currently, when the temperature is exceeded, the pin goes to high and it makes the sound or it triggers the lighting. And when it's done sending the information to this board, then this sound and the lighting goes back to low, like the sound is off, the lighting is down.
My name is Tusime Emery Queen. I'm explaining board 4. So board 4 receives the data from board 3 and it displays it on the serial monitor. This board also monitors for any alert signals from board 3. If the alert pin is high, it logs and displays a warning message on the screen. And board 4 also processes the data it receives by passing the temperature and humidity values and printing them in a readable format. This board helps us to visualize the data in real time, and we can keep track of environmental conditions with a quick class. So communication between board 3 and board 4, it goes both ways. So board 4 connects back to board 3 using a pin ready 4 to confirm when it's ready to receive data, which ensures that no data is missed. So let me show what is on the serial monitor. Okay, let me show you. So on the serial monitor we can see that the temperature is 28.50 and past humidity is 59. So board 4 is basically for displaying the alerts and data. So for example, here you can see the temperature is a bit high compared to what we had set. So this is the alert message it is giving us.
My name is Rachel and I'm here to conclude. So in this setup we have 4 Arduino boards. Board 1 reads the data from the DHT sensor and sends to board 2, which saves the data. Then after saving, it sends to board 3, which compares the data received and the threshold. If the temperature is higher than the set threshold, it's going to set the alert. And then after that, it's going to send the data to board 4 for display in a human readable format. So this has been our project, and we are group 19, and thank you so much for watching.